Bismillahirrahmanirrahim. Today we will continue chapter number 2, real and complex numbers, and solve question number 4 and question number 5 and question number 6 of exercise 2.1. Our objective for today's lesson, the students, you will be able to depict real numbers on a number line. You know that what is number line? Number line is the line on which numbers are written in this form. So this is the number line. Some of the definition that are useful in today's lesson. What are real numbers? Real numbers are those numbers that are invented till now are real numbers. So all the numbers in the universe are known as real numbers except imaginary numbers. So we will discuss these imaginary numbers in later exercise. For now, all the numbers in the universe are known as real number, or we can say that all the number on the number lines are real numbers. Second is, what are rational numbers? So the rational numbers are those numbers that can be expressed as the ratio of two integers, like we have 1 by 3, 2 by 1, 6 by 8. So all these are rational numbers. And what are irrational numbers? Irrational numbers are those numbers that cannot be expressed as the ratio of two integers, like square root 2, square root 5, pi. So all these are irrational numbers. Exercise 2.1, question number 4, represent the following numbers on number line. Here we have fraction 2 by 3 and we need to represent this fraction on the number line. 2 by 3 is positive, so we consider this positive side of a number line. Since there is no whole number, so it means that we need to plot this 2 by 3 between 0 and 1. 2 by 3 means that let's say if we have a circle and we divide it into 3 equal parts and 2 parts are shaded, so we write it over here as 2 by 3. So same goes with the number line. So we divide 0 to 1 into 3 equal parts and then count 2 from 0 to 1 and 2. So this is the representation of 2 by 3 on number line. Now let us consider another example, minus 4 by 5. Minus 4 by 5, this negative sign shows that we will consider negative side of a number line. Here we do not have any whole number, so we plot this 4 by 5 between 0 and minus 1. Now we divide 0 to 1 into 5 equal parts. So how we divide into 5? 1, 2, 3, 5. 1, 2, 3, 4, 5. Here it is divided into 5 parts. These parts are not equal, but when you draw this number line on your notebooks, keep in mind that these parts must be equal. So now we count 4 from 0. So 0, 1, 2, 3, 4. So this is the minus 4 by 5 point on number line. Now come to another question, which is minus 2 pi by 8. This is the mixed fraction. Since this is negative, so we consider negative side. Now minus 2, this is some whole number. So we plot this minus 2 by 5 between minus 2 and minus 3. Now we divide minus 2 and minus 3 into 8 equal parts and then consider the fifth one. Here I write it over here as this is minus 2, this is minus 3. Now divide it into 8 equal parts. Now there are 8 equal parts, 1, 2, 3, 4, 5, 6, 7, 8. Now from minus 2 to minus 3, I need to move 5 points. So 0, 1, 2, 3, 4, 5. So this is minus 2 into 5 by 8 point. Now when you are drawing on your notebooks, please consider the distance between minus 2 and minus 3 little long. Now come to question number 5, that is, give a rational number between 3 by 4 and 5 by 9. It means that if on a number line, let's say this is 3 by 4 and this is 5 by 9. They are asking that find a number that is between these two point. So the middle point that is between these 2 points is also a rational number, so we find this midpoint. So how do we find this midpoint? We know that this midpoint divides this into two equal parts, 1 and 2. So what we do, we add 3 by 4 plus 5 by 9 and then divide it by 2. Now we do just simple simplification. 3 by 4 plus 5 by 9, there we have different denominator, one is 4 and one is 9. To make the denominator alike, what we will do, we will multiply 3 by 4 by 9 and 5 by 9 by 4. So 3 into 9 27, 5 into 4 20, 4 into 9 36 and 9 into 4 36. Now the denominator is alike, we add the numerator simply. 27 plus 20 divided by 36. Now here we have 27 plus 20 divided by 36 multiply by 1 by 2, because 1 2 is in denominator, so we can write it in this form. Now 36 multiply by 2 and 20 plus 27, we have 47, and 36 into 2 is 72. So 47 divided by 72 is the number that is between 3 by 4 and 5 by 9. Now come to question number 6. Question number 6 is express the following recurring decimal as the rational number. Here we have 0.5 dash. This dash represents that this number is a recurring, and we know that recurring decimals are those decimals that shows the decimal expansion with same pattern. Here we have dash on 5, so it means that 5 is keep on repeating. So to solve this, let us consider this 0.5 as x, and we can write it in this form. When we do not put dash, we can write in this form, as this is a recurring decimal representation. Since we have only one digit 5 repeating infinitely, therefore multiplying both sides by 10 of equation 1. Here I am multiplying it by 10. Why? Because 5 is keep on repeating, so it means that one number after decimal is repeating, so we are multiplying it by 10. So if we have 0.69, so it means that it is 696969 so on. So here two numbers are repeating, so we multiply them by 100. Similarly, if three numbers are repeating, we multiply them by 1000. Now come back to the question. Now multiply by 10 of equation 1, we have 10x is equal to 10 into 0.55 up to so on. So 10x is equal to 5.555 so on. So this is equation 2. Now we subtract equation 1 from equation 2. We have 10x minus x is equal to 5.55 minus 0.55 up to so on. So 10x minus x is 9x, and 5.55 minus 0.55 up to so on is 5.00. How it is? Let's say 5.55 so on and 0.555 so on. 5 minus 5 0, 5 minus 5 0, 5 minus 5 0, 5 minus 0 is 1, and this point will be 5 minus 0 is 5, and this point will remain same over here. So we get the answer 5.00 up to so on. 9x is equal to 5. Here 9 is multiplying, so on the other side it will be divided. So x is equal to 5.9. It means 0.55 is equal to 5 by 9. Now let's solve another question. Here we have 0.13. It means that 13 is recurring, so 13 keep on repeating. So let us consider x is equal to 0.13, 13 and 13 up to so on. Here we have two numbers that are repeating, so we multiply equation 1 by 100. So we have 100x is equal to 100 into 0.131313. We left with 100x is equal to 13.1313. Now we have equation 1 and equation 2. Subtract equation 1 from equation 2, we get 100x minus x is equal to 99x, and similarly 13.1313 so on minus 0.131313. 3 minus 3 0 0 0 0 0, and 13 minus 0 is 13, and point will be same, so we are left with 13. And here 99 is multiplying, so on the other hand side it will be divided. So 0.13 is equal to 13.99. So this is the decimal representation of recurring decimals. Your follow-up work for today's lesson is you will solve exercise 2.1 question number 4 part 3 part 5 and part 6 and question number 5 part 3. That's it for today's lesson. Thank you for watching.